Hello everyone. In today's class, we are going to study about the free electrons. So, yesterday's class, we have studied about the valence electrons. Based on the number of valence electrons, we can decide whether the particle or the material is the conductor or insulator or semiconductor. Now, we are going to discuss about the free electrons here. We know that the electrons always move around the nucleus of an atom in a different orbits. So there are different orbits are there around the nucleus. The electrons in the inner orbits which are close to the nucleus are tightly bound to the nucleus, and as we go away from the nucleus, this binding goes on decreasing, so that the electrons in the last orbit are called as valence electrons. As yesterday only we have discussed, are quietly loosely bounded. So what we are going to study here, that free electron which is move around the nucleus of an atom with different orbits. The inner orbit electrons are tightly bonded with the nucleus, and outer orbit electrons are loosely bonded electrons. The outermost electrons we call it as a valence electrons. Okay, the valence electrons are also weakly attached to their nuclei, that they can be easily removed or detached from the nucleus easily. Such electrons are called as free electrons. So what is the definition here? The valence electrons which are very loosely bonded to the nucleus of an atom, that is called as free electron. So the free electrons move at random from one atom to the another in the material. So if one material is there, means the free electrons are always moves randomly. In fact, they are so loosely attached that they do not know the atom to which they belong. So that much of loosely bound will be there. Since a small piece of metal has billions of atoms, if we consider small piece of a metal, it has billion number of atoms. One can expect a very large number of free electrons in a metal. If billions of atoms are there, means in one atom so many free electrons are there. So that very large number of free electrons in the metals are there. Suppose if I consider 1 cubic centimeter, the free electrons number is about 8.5 into 10 to the power 22 electrons will be there at room temperature. Okay, so based on this, we again classified the substances into three categories. A substance which has a large number of free electrons at room temperature is called conductor. Okay, it is a conductor of electricity. For example, metals. If a voltage source is, suppose if I applied across the wire of any of the material, free electrons readily flow through the wire. This constitutes electric current. The second one is called the substance which have very less number of or very few number of electrons. Free electrons are called as insulators at room temperature. Examples, non-metals. And third one is the class of substances which are semiconductors. Their name implies they are neither conductor nor insulators. Okay, in between these two properties they will act. Those are called as semiconductors, which partially no current will flow through these substances, which are rubber, ceramic particles, paper, and most of the liquids are all semiconductors. Now it is all about the free electrons. Now I am going to discuss what is electric current. So it is very important here. What is electric current? The directed flow of free electrons. Directed flow of free electrons is called as electric current. whenever we say there is a wire, when we applied some voltage here, okay, we say it as a it conducting or it is not conducting based on the number of electrons. So when we say there is a electric current, that means there should be a directed flow of current. There should be one direction for the flow of the electrons. The flow of electric can be beautifully explained by this diagram. Here I consider one conductor which is connected to the EMF source or a battery, I can say. Okay. When an electric pressure is applied, this is nothing but what? If I connecting a battery means when the electric pressure is applied, the free electrons now being negatively charged will start moving towards the positive terminal of the circuit, positive terminal around the circuit. This directed flow of electrons is called electric current. Inside the conductor, they have free electrons which are moving in a directed flow. This is, I consider it as a copper slip or any of the conductor. Current is a flow of electrons, and electrons are the constitutes of matter. Okay, therefore electric current is also matter. Say here 3 points we should remember. Current is flow of electrons. So electrons are constituting of matter. So electric current is also called as a matter which is in motion. So second thing you need to remember is the actual direction of the current is from negative terminal to the positive terminal through that part of the circuit external to the cell. Here we can see here in this figure the electrons are moving from negative terminal to the positive terminal which is external to the cell. However, prior to the electron theory, it is always flowing in the conventional direction, that is from positive terminal to the negative terminal of the cell. This convention is also firmly established in this later, still use it is. So according to the conventional current theory. So what is the unit of current here? Unit of current is, I represent the current in terms of I. It is charge divided by T. The strength of electric current I is the rate of flow of charge or the rate of flow of electrons, that is charge per second, is called as current. That is the unit of current. The charge Q is measured in terms of coulombs and time is in terms of seconds. Therefore, the unit of electric current will be coulombs per second. If 1 coulomb of charge I consider flowing through the conductor in 1 second of time, then current I will be is equal to 1 ampere. So this is about the today's class. So we will discuss about the electric current, whether it is a scalar quantity or vector quantity, what are the types of current in next class. Thank you.